Right, this will be our final exam review for MR with support. So I'm gonna go on the screen and start my questions. So number one wants me to identify the fallacy in the given argument. Each of my brother's three dogs has fleas, therefore all dogs have fleas. So on that, I went with a hasty generalization, right? Just because your brother's three dogs all have fleas, does that mean that all dogs have fleas? So you're trying to generalize all dogs by those three. Y'all, same thing on this second one, identify the fallacy in the given argument. A television commercial shows two people who fall in love while wearing a certain brand of blue jeans. So the fallacy I went with that was appeal to emotion. Okay, so remember, and they're doing that because they want you to love those jeans like those two people have love for each other, right? They're appealing to your emotion of love. Okay, all right, number three, convert 24 feet to inches. So 24 feet to inches. All right, so to do that problem, you start with 24 feet. And this is where we were doing our unit conversions. So we need to turn our feet into inches. So for every 1 foot, there is 12 inches. All right, and that's all the conversions I need, right? Because my feet cancel and I'm going to be left with inches. So to do that problem, anything on top gets multiplied. So 24 times 12 is going to give us 288 inches. Okay, so that's the main thing you're doing on those. Just look what units are giving you to start with and look what inches or what units they want you to finish up with. My number four, a commuter train travels 55 kilometers in 26 minutes. So 55 kilometers in 26 minutes. What is the speed in kilometers per hour? So they want me to figure out what is the speed in kilometers per hour. All right, so let's see what they're giving me. They're giving me 55 kilometers in 26 minutes. So I got to convert from the minutes into the hours. Kilometers is good because it's what I'm finishing up with is kilometers also. So all we got to do is finish by figuring out how many minutes is in an hour. So 1 hour is 60 minutes. So 60 minutes is equal to 1 hour. So now, see, I had to have the minutes on top so that they would cancel with those minutes on the bottom. So to do this problem, I'll end up with kilometers on top and hours on the bottom. So now everything on top gets multiplied, and then we divide that by what's on the bottom. So 55 times 60, it's going to give me 3,300, and then divide that by 26. And let's see, they want me to go to the nearest tenth, which is 1 decimal place. So that'll be 126.9. And the units would be now kilometers per hour. And that's the trick on those, is just get your stuff to cancel out like you need it so that you can end up in the correct units. Number five, carry out the indicated unit conversion. Round your answer. So there are 8 ounces in a cup. So they're giving you the breakdown. There's 8 ounces in 1 cup. There's 4 cups in 1 quart. There's 4 quarts in 1 gallon. So using these conversions, they want me to convert 8 gallons into ounces. And see, they gave me the 4 conversions I'm going to start with, okay? So I'm going to start with my 8 gallons, because that's what we're given. And what we got to do is turn these gallons into ounces. So let's see, we're going to work backwards because we're given gallons. So we know that every 1 gallon is 4 quarts. So 1 gallon is 4 quarts. So the gallons are going to cancel. Now we got to turn quarts into cups. So for every 1 quart, there is 4 cups. So now the quarts will cancel and I'm left with cups. But now I got to turn my cups into ounces. So for every 1 cup, there is 8 ounces. So now my cups are going to cancel and I'm left with ounces. So everything on top is going to get multiplied, and all we got on bottom is a bunch of ones. So if you divide anything by 1, it's still going to be itself. So really all we got to do is multiply the top. So 8 times 4 is 32, times 4 is 128, times 8 is going to give me 1,024 ounces. So that's the trick on those. Just start with your units and get canceling as you go on those. All right, same thing for number 6. They want us to use a chain of conversions with familiar measures of time to convert 6 weeks into seconds. Ooh, so we're going to turn 6 weeks into seconds. So that's going to be a lot of seconds. So here we go. We got 6 weeks we're starting with. So the only conversion I know to start with from a weeks would be that a week has 7 days. So for every 1 week, there are 7 days. So the weeks are going to cancel and we're in days now. So let's see what's next. We know that for every 1 day, there is 24 hours. So the days will cancel and we're in hours. So now let's see, we got to go to seconds. So let's see, for every 1 hour, there are 60 minutes. So I'm out of hours and I'm down to minutes. So I know that for every 1 minute, there are 60 seconds. So now my minutes will cancel and I'm going to be left with my seconds. Whew. So since everything's on top, it's all going to get multiplied. So 6 times 7 times 24 times 60 times 60 is going to give me 3,628,800. So that is 3,628,800. And remember, I'm now in seconds. So we knew that'd be a lot of seconds in, what was it, 6 weeks, okay? All right. Recently, 1 US dollar was worth about 12.73 Mexican pesos. So 1 US dollar was equal to 12.73 Mexican pesos. They want to know how much would 335 US dollars be worth in Mexican. So be worth in Mexican pesos. So what are we starting with? $335. So that I'll just use dollars for US dollars. And remember, this is US. They gave me the conversion up here. Every 1 US dollar is worth 12.73 pesos. So look, my US dollars are going to cancel. So all we got to do is multiply $335 times 12.73 and that'll give me $4,264.55 in pesos. Okay, so dollar must be worth a lot more than the peso, okay? All right, y'all, so that was the first 7. Number 8's the same thing. So they got a little table here that says currency, European, Euro. And then this one says US per Euro is 1.163. And this one is Euro per US dollar is 0.8598. So their question is, you return from a trip with 230 euros, so you got 230 euros. How much are your euros worth in US dollars? So how much in US dollars? All right, so we're starting with 230 euro. The conversion we want is US per euro. So let's make our little block. So there's, for every euro, we get 1.163 US dollars. So 1.163 US dollars per euro. So look, my euros canceled. That's why the euro had to be on the bottom. So it looks like we're going to multiply that and see what we get. So it's 230 times 1.163. And this one I'm going to round to the nearest cents. So that looks like 267.49. All right, y'all, let's see number 9. Write the number in ordinary notation. So it's 2.3618 times 10 to the 4th. So since that's a positive exponent on the 10, that means I would move right 4 units. So 1, 2, 3, 4. So that'll make my number 23618. And since the decimal is after the last number, you don't need to write it. Okay. Now, if that would have been a negative, I'd have went to the left with that, okay? Prorate the given expenses to find the monthly cost. So this is number 10. Kelco pays $300 per month for food. So $300 for food. Semi-annual health insurance premium. So semi-annual health, $1,400. And an annual car insurance premium, annual car, of $550. So we want to prorate these expenses to find the monthly cost. So semi-annual health, that means 2 times a year. So 2 times a year, we're going to pay $1,400. Annual car insurance means 1 time a year. So 1 time a year, we're going to pay $550. And then this was what, $300 a month for food. So that'd be times 12 on our 300 for food. So we got to add all these up and divide that by 12 to see what our monthly fees will be. So we got $1,400 times 2. That's going to be $2,800. 1 times 550 is going to be $550. And then 12 times 300. So per year, she's spending $3,600 just on food. So add those all up. So 3,600 plus 550 plus 2,800. So this all gives us a total of $6,950. We're now going to divide that by 12 because that's her yearly cost. So that's $6,950 divided by 12 months. So let's see where I'm rounding this off. Round to the nearest dollar. So since that's a 0.1, we're going to round that to a 579. So when they say round to the nearest dollar, they don't want no decimal places left, okay? All right, y'all, moving on. Find the monthly interest payments in the situation described. Assume that monthly interest rates are 1/12 of annual interest rates. Ashton maintains an average balance of $900 on his credit card, which carries an annual interest rate of 24%. So annual rate, 24%. All right, so we're finding the monthly interest payments. Okay, so we just want to find what the interest is on that card per month. So we got to take this 24%, turn that into decimal form. So move it left twice, so we get 0.24. So now, that's his yearly rate, but remember, we're looking at his monthly interest. So the monthly interest will take that 24%, and monthly would be 1/12 of the yearly. So you're either going to multiply by 1/12 or you're going to divide by 12 to see what it is every month. So 0.24 times 1 divided by 12. I put my parentheses in, my fractions in parentheses. That gives me 0.02. Now look at this. If you'd have took the 0.24 divided by 12, because there's 12 months in a year, you still would have got 0.02. So either way. So now, the interest rate per month is what we hit that $900 with. So 900 times 0.02% is going to give us his monthly interest, which looks like is $18 a month. So if he maintains a $900 balance, then he's paying $1,800 just in interest alone on that card, okay? So that's what you do. Take the annual rate, divide by 12 to get the monthly rate, and then multiply the balance times the monthly rate to get the monthly interest rate. Now, y'all, so number 12. Use a compound interest formula for compounding more than once a year to determine the accumulated balance after the stated period. We got 3,000 deposit, APR of 8%, monthly compounding for 3 years. So that formula was A equals P, which is the principal balance, times 1 plus annual percentage rate divided by N, which is the number of compounds, all raised to the N times Y, which is the number of years. So P is my starting balance, 3,000. I'm going to multiply that by 1 plus, remember, 8%. You got to turn into a decimal, so you got to add a 0 to make that a 0.08. So that'll be 0.08 divided by N, which is the number of compounds per year. So since this is monthly compounding, that's going to be 12 times per year. And then the exponent will be 12 times the number of years, which is 3. All right, so watch this. I'm going to put this in the calculator. 3,000. Now you can use the times if you want to. Times parenthesis 1 plus 0.08 divided by 12. Close your parentheses and then use your arrow up key for the caret. to get the exponent, which is 12 times 3. So you'll punch all that in there. Now we're going to round around into the nearest cents. So this will be $3,810.70. Since that one's got a 1 after it, it's going to stay a 1. So you started with 3,000. It's going to be about 3,800 after 3 years. All right, this one says you want to have, so you want $75,000 college fund in 15 years. How much we have to deposit now in an account with an APR of 6% and monthly compounding. So this is the one where you had to find the principal, and the principal was equal to your A, which is the amount you want, divided by 1 plus your APR divided by N, all raised to the N times Y. So let's see, the amount we want left is the 75,000. So now we're going to divide that by 1 plus my APR. So what's my APR? 6%. Got to move that left twice. So I'm going to add a 0. So that's going to be a 0.06. Divided by N, monthly was 12 again. So you got 1 plus 0.06 divided by 12. And then this is 12 times the number of years, which is 15. All right, so watch how I do this. On the calculator, you got to do the 75,000 divided by, you got to put the whole bottom in parentheses. So parentheses, 1 plus 0.06 divided by 12, close your parentheses, and then arrow up to get the exponent, which is 12 times 15. So this is going to tell me how much money I got to deposit into the bank account in order to have $75,000 in 15 years. All right, y'all, so when I hit that, that's telling me I need at least $30,561 that are going to the nearest cents. So that'll be a 0.18. So keep that at 8 since the number after it was a 2. So if you start with 30,000, you'll make about $45,000 in 15 years. So that's not bad if you want to do stuff like that to invest in future colleges, okay? All right, so listen here. Suppose you start saving today for a $5,000 down payment. That you plan to make on a condo in 2 years. Assuming that you make no deposits into the account after your initial deposit, the account has annual compounding. So that's simple compounding when it's just once a year. APR is 5%. How much do you need to deposit now to reach your 5,000 goal in 2 years? All right, so that's the same as we just did up here. So we got our P equals A, which is our $5,000, divided by 1 plus interest rate 5%. So move that left twice. So that's going to be a 0.05. Annual compounds mean just once a year, and then that'll be 1 times 2 years. So it becomes simple because of that 1, because you really, when you divide 0.05 by 1, it still stays 0.05, okay? So here we go. We got a 5,000 divided by parentheses 1 plus 0.05 divided by 1. In my exponent on the parentheses is 1 times 2. So you could have made this 1 plus 0.05 And then you could have made that a 2 because that 1, that's all that's doing to it. So to reach that goal, you would have to have $4,535. And let's see, rounding that to the nearest cent would be 0.15. So you'd have to start with $4,500 at an annual compounding 5% APR in 2 years to have $5,000 is your goal, okay? Let's see what we're on, 15. Calculate the amount of interest you'll have at the end of the indicated period. You invest $900 in an account that pays simple interest of 3%. So simple interest of 3% for 5 years. So the formula for simple interest was A equals P times 1 plus APR times years. So here's my P is $900 times 1 plus APR 3%. Let's see, move that left twice. So that'd be a 0.03 times the number of years was 5. So let's punch that in. 900 times parenthesis 1 plus 0.03 times 5. Close those parentheses and hit enter. And we get $1,035. So that's our total we have after the 5 years. But remember, we're just looking for the amount of interest that we'll have at the end of that time. So we take the total, which is 1,035. We subtract the 900 we started with. So minus 900. That gives me a total interest that I made of $135. And if you round that to the nearest cent, you just have to add 2 zeros on that, okay? All right, 16. The blank in financial formulas is the balance upon which interest is paid. That would be your principal. The principal in financial formulas is the balance upon which interest is paid. Okay. 17. Blank is interest paid only on the original principal and not on any interest added at later dates. That would be simple interest. So simple interest. So simple interest is interest paid only on the original principal and not on any interest added at later dates. Okay. Remember, compounding is added at later dates because they compound it so many times a year. So each time they compound it, you're getting interest added, and then you're taking a percent of all that that's being added together. All right, 18, the blank is the actual percentage by which a balance increases in 1 year. That would be the APY, which is the annual percentage yield. So the APY is the annual percentage by which a balance increases in 1 year. All right, so 19, what is continuous compounding? How does the APY for continuous compounding compare to the APY for, say, daily compounding? Explain the formula for continuous compounding. So they gave you choices on that, and the one I picked was the choice that said this: compounding infinitely many times per year is called continuous compounding. So continuous compounding can be infinite. The APY for continuous compounding is only slightly larger than the APY for daily compounding. The formula for continuous compounding is a special form of the compound interest formula. Okay, so that was stuff we did way back in the past, right? Okay, 20. A sample statistic and margin of error are given. Find a confidence interval likely to contain the population parameter of interest and answer the question. So 10 years ago, according to government records, 17% of the population, so 17% of the population had no health insurance, and that was 10 years ago. So 10 years ago, 17% had no health insurance. This year, a poll revealed that 18%, so this year, they did a poll and 18.8% were without insurance. The margin of error, so the error was 1.4 percentage points. Find the confidence interval for the true percentage without insurance this year. And then they want to know, can we conclude that the percentage without insurance has increased from 10 years ago? So remember, my confidence interval takes the amount they gave you, we subtract the margin of error, and then we take the amount we got and we add the margin of error. So your confidence interval is going to be from 18.8 minus 1.4 to 18.8 plus 1.4. So let's figure this left side out. 18.8 minus 1.4 gives me 17.4%. Now I got 18.8 plus 1.4. That's going to give me 20.2%. So this is the percentage that I got from the new data. So can I conclude that has increased from 10 years ago? Well, 10 years ago, it was at 17%, and the lowest I got this year was 17.4%, which is definitely a little bit higher than 17%. So we would say yes. Now, if my numbers had been like 16 point something to 19 point something, then I might not could have been as sure, because I would have had values lower than the 17% that could have been in the range, okay? All right, 21. Same thing. So following the Republican National Convention, a poll of voters in central Illinois community showed that 57.1% would choose the Republican ticket to win over the Democrat ticket, no matter whom the Democrats chose for vice president. The margin of error was, so error is 5.4 percentage points. So should the Democrats expect to lose central Illinois? So if our data gives us anything over, say, 50%, then we would say yes to that, okay? So our margin of error is going to be from 57.1 minus 5.4 to 57.1 plus 5.4. So let's see what we get. 57.1 minus 5.4 gives me 51.7 to 57.1 plus 5.4 is going to give me 62.5. So since our lowest value is 51.7, which is over 50%, which is what you need to win the majority, yes, they should be concerned. All right, y'all, what are we on? 22. Identify which type of sampling is used in the example below. To avoid working late, a quality control analyst simply inspects the first 100 items produced in a day. Repeating, to avoid working late, a quality control analyst simply inspects the first 100 items produced in a day. That would be what we would call convenience. He's choosing what's convenient for him to use to get his job done. 23, same question. A sample consists of every 20th student who leaves the library. So I'm choosing the 20th person that leaves the library, then the next 20th person, and then the next. When you do that, remember that was systematic. Okay? And then remember we had random and then stratified. In order to answer the question below, which of the following types of study would be the most appropriate? Does the new medication relieve depression? So you're looking at a medicine for depression. So anytime, remember that we was dealing with medicines and we were checking them out, we wanted an experiment with double blinding, right? We didn't want the interviewer to know or the people being given the placebos and the medicines to know which was being given to who, okay? All right, same thing. In which of these four soils types will the plants grow faster? Well, if you're looking at soil types of growing plants, then we would call that an experiment without blinding, right? You're not giving placebos or anything. You're just going to plant some plants and see which one grows the best. Identify the variable as either qualitative or quantitative. So on 26, population of a town. Population of a town would be quantitative because it's a big number, right? Alrighty, 27. The movie critics ratings. So movie critic ratings of a new movie of a scale 0 to 10, where 10 is the best movie ever seen and 0 is the worst movie ever seen. When you're doing that, your rating stuff, that is qualitative. Okay? 28. Same thing. The marital status of individuals. So married, not married. So married status. Once again, I would say that would be qualitative. All right, 29. Find the mean. So find the mean for the given data. So I got 13, 19, 16, 13, and 18. So find the mean, which remember the mean is the average. So to find the average, you add them all up and divide by how many you had. So what I'm going to do is I'm going to add 13 plus 19 plus 16 plus 13 plus 18. And I'm going to take that whole total, and I had 5 tests, so I'm going to divide by 5 and see what that gives me. All right, so here we go. 13 plus 19 plus 16 plus 13 plus that 18 equals 79 divided by 5, and that's going to give me 15.8. Now remember, your average has to be between the lowest number and the highest, and 15.8 is in between those, so that would be my average. All right, 30. A store manager kept track of the number of newspapers sold each week over a 7-week period. The results are shown below. So I had 92, 73, 219, 143, 258, 248, and 239. And they want me to find the median. So the median number would be the middle number. So to do that problem, I'm going to put these numbers in order. So it goes from 73 to 92, 143, 219. What's next? 239. What's next? 248. And then 258. So remember, the median is the middle one. So when it's an odd number, you pick exactly the middle. So let's see, I got 7 of them. So the middle one would be 219. So my median is 219. All right, y'all, let's see. It was 30, so this will be 31. Find the mode for the given sample. So I want the mode. So they're giving me -20, -45, -46, -45, -49, -45, and -49. So the mode is the one that happens the most. So let's see, 20 only happened once, 45 happened 1, 2, 3 times, 46 only 1 time, 49 twice. So since -45 happened 3 times, the mode is -45. The odds on or against your bet are 5 to 6. So the odds are 5 to 6. You bet 36 and you win. How much will you gain? So you got your $36 times your odds, which are 5 to 6. So basically, take that $36 times 5 divided by 6. Put that 5 divided by 6 in parentheses, and you get 30. Now watch this. You could do 36 times 5 divided by 6. Guess what? Calculator's still going to give you 30. So if you bet $36, you're going to win 30. All right, on a multiple choice test, each question has 5 answers. So each question has 5 choices. If you make a random guess on the first question, what is the probability that you are correct? So if you make one choice, and out of a possible 5 choices, so that would give you what, a 1 out of 5 chance that it could be wrong, 4 out of 5 chance, 1 out of 5 chance you're right, 4 out of 5 chance you're wrong, okay? A bag contains 2 red marbles, 3 blue marbles, and 7 green marbles. If a random marble is drawn from the bag, what is the probability that it is blue? So how many blue did we have? We had 3 blue that we started with. And then we got to see how many total marbles we had. We had 2 red, 3 blue, that's 5. 5 plus 7 greens is 12 marbles. So the odds, when you got 3 blue out of 12 marbles, that would reduce to what, a 1 over 4. All right, the probability that Louis will pass his statistics test is 0.32. So pass is 0.32. That's his probability. Find the probability that he will fail. So find probability he fails. Well, remember, probabilities go from 0 to 1, okay? So the highest probability is 1, which would be 100%. So if we want to see what the probability is of him to fail would be, we take 1 minus the probability that he would pass, so that what's left will give me the probability that he'll fail. So 1 minus 0.32 is going to give me a 0.68. Now, if you take the probability that I'm passing, add it to the probability of him failing, that's got to give you 1, which is like 100%. Okay? All right, 36. So they want to describe the method, theoretical, relative frequency, or subjective, and compute or estimate the following probability. So an experiment consists of drawing 1 card. So 1 card from 52 card deck. What is the probability of drawing a black face card? So a black face card. Well, let's think there's what do you call it? Jack, Queen, King, Jack, Queen, King, spades. So there's 6 black face cards. Out of the total, which was 52 total cards. So let's see, 6 divided by 52. If you don't know how to reduce that, just punch 6 divided by 52 on the calculator. It'll give you a decimal, and then hit math and enter twice to turn that back into a fraction. And that looks like that reduced that to a 3/26. So basically all they did was divide both these numbers by 2 to reduce that down. All right, y'all. 37. Same thing. State the method, theoretical, relative frequency, or subjective, and then answer the question. What is the probability of being dealt a pair of aces in a 5-card hand? So pair of aces in 5-card hand. So that once again would be theoretical. And if I didn't say that on the last one, it was theoretical also, because you just had to look and see in theory how many different ways you could get those combinations, okay? And I said the theoretical method should be used because the best approach to finding the probability is counting all the possible hands with a pair of aces. So count all possible hands with pair of aces. All right, 38. Pizza House offers 5 salads, 4 pizza, and 4 desserts. How many combinations of 3-course meals can be ordered? So how many combinations of 3-course meals? Well, remember, to find combinations, you're just going to multiply everything. So the combinations would equal 5 salads times 4 pizzas times 4 desserts. So if we multiply all those, 5 times 4 is 20. 20 times 4 gives me 80 combinations that I can get from those choices. The price of a computer component is decreasing at a rate of 11% per year. So whoops, decrease at 11% a year. State whether this is linear or exponential, and then if it costs $120 today, what is cost in 3 years? So what is cost in 3 years? So since we're dealing with percents, that is exponential. Remember, linear was the same amount each year. All right, so since that's exponential, you take the starting amount, and we're decreasing, so we're going to subtract 11% a year. So for the first year, you got 120 times 11%, which is 0.11. So 120 times 0.11 gives me 13.2. Now, subtract take that 120 minus the 13.2 that it decreased that year. In your next year, you're starting at 106.8. Times that times 0.11, which is 11% for that year. So 106.8 times 0.11 gave me 11.748. Subtract that from the 106.8 and you start with 95.052 times your 11%. So this is taking care of the third year, and that gave me 10.45572. I'm just using all my decimal places. I'll round it at the end when I put it into the nearest cents, okay? So to get my final amount, I take that 95.052, subtract that year's interest, which was 10.45 basically. That gave me a total of 84.596. And I rounded that off to an 84. Since that's a 9 followed by 6, I rounded everybody up to a 60. So remember, exponential, you got to subtract the amount each year or add it if it's an increase. Now 40, this one says the population of a town, so population, increasing by 638 people per year. State whether this is linear or exponential. Well, that is definitely linear because it's the same amount. So that one is linear. And if the population is 1,300 a day, so 1,300 a day, what population in 4 years? So what we got to do is figure out how much it changed in 4 years. So it's doing 638 people per year. So that's people per year. And we're doing it for 4 years. So see, my years cancel, and this will tell me how many people it grew in them 4 years. So 638 times 4 means it grew by 2,552. So now we take the smarting amount, which was 1,300 people, plus the 2,552 people that it grew by, and our final population is going to be 3,852. But this one was linear because it always went up by 638 people a year. It wasn't by percents, okay? All right, 41. During the worst periods of hyperinflation in a certain country, the price of food increased at a rate of 30% per month. So 30% month increase. State whether that's linear or exponential. Well, it's percents, so this is definitely exponential. So if your bill was 120, so it was 120 a month, what will it be 3 months later? So it's 120 a month. Hyperinflation is causing it to go up 30% a month increase. So what will it be 3 months later? So on this one, we started with our 120. And it's 30%, which will be 0.30. So for the first year was $36. Add that to the 120, you get 156 times its 30% for its month, gave me 46.8. Add that to the 156, you get 202.8 times the 30% for that month was 60.84. See, it's not changing the same every month because it's a percent. Now, take that 60.84, add it back to the 202, and you get 263.64. Now, this one wanted me to round to the nearest dollar, so that would be $264. So please check how they want you to put these answers in by the nearest dollar, the nearest cents, round to the nearest tenth, okay? Alrighty, so this one I just want to show you. They're giving us a graph down here. In 2001, they opened the used car sales, and this graph shows the number of cars sold as a function of time. So here's your time, which is years, and here's the cars sold. What is the approximate number of cars sold in 2003? So we come down here and find 2003, which is the line right here. We go straight up it to see where that point is, and then we look over here where we think we are on the Y values or on the number of cars sold. So that is in between where the 5 and 600 would be. So if you look over here, the only one that would be in between the 5 and 600 was the 550. So look at the year they're giving you, find where your dot is for that, and then see that Y value for your values, okay? All right, then I'm going to do 43 here on the graph. The following graph represents a function. Describe the function in words. So here they're giving me years, and here, average age of death. So it looks like in 1980, oh, what's that, about 65 was the average age of death. Over here, almost to 2005, which is probably around 2004. It was right around 80 or so. But if you notice, that's almost a straight line. So that's a steady increase. So notice I picked A because it said the function shows a steadily increasing average age of death between 80 and 2004. So I went with A on that. All right, so we're not far from it. So let's see. On this one, I'll go to 44. Write an equation and use it to answer the question. The cost of renting a car is $30, so $30 flat, plus an additional 0.14 cents per mile. How far can you drive for $99? So how far for $99? So let's come up with our equation. It's going to be R equals our starting amount, which is 30. We're adding this, so that's going to be plus our rate is 0.014 cents per mile, which is what they got for the end. So the rate is $30 plus 4 cents per mile. So they wanted you to figure out how far you could go for $99. So you got to put $99 in for your R, and then bring down your formula. Oh, that was 14 cents, y'all. My bad. That should be a 1-4. So 14 cents a mile. So what I do, I first would subtract 30 from both sides. So that'll give me 69 equals the 0.14 miles. And then I would divide both sides by the 0.14. So this side, those cancel. You get your M or your miles. So let's see, 69 divided by 0.14 is going to give me, let's see, 492.8. They're rounding to the nearest miles. So that would be 493 miles. But I'll tell you on this one, if you pick the right equation, they're going to have the right amount by it for you, okay? In the following situation, state whether two variables are related in a way that might be described by a function. If so, identify the independent and dependent variables. You're taking a road trip in a car and want to know how far you've traveled at various times during your trip. Yeah, you can definitely relate that with a function. Your independent variable is going to be time. Your dependent variable dependent variable is going to be your distance traveled. Now remember this, time can never be the dependent variable. Time can only be an independent variable, okay? 46, same thing. Volume of a gas tank, cost to fill the tank. So the volume of gas tank and then the cost to fill. So they had you picking some out. So I went with this number B that says as the volume increases, well, as the volume of that tank increases, I'm going to expect the cost to increase also. Right? The more gas you put in it, the cost is definitely going to increase also. All right, 47. Oh, let me get this paper off. All right, so 2 more to go. 47. During the month of January, the depth of snow at a base of one ski resort decreased. So it decreased 2 inches a day. On December 31st, there was a depth. So December 31st, it had a depth of 68 inches. Find an equation that represents this linear function and graph the equation. Use the graph to estimate the depth of snow on January 28th. Okay, so what depth on January 28th? All right, so to do that one, we got to come up with our y equals. So y equals, let's see, what starting amount we had? I said it started at 68 inches because that was on December 31st. It's decreasing, so it's going to be minus 2 inches times the number of days. And I'll just call that a D. So 2 inches a day it decreases from the 68. So they want to know how much the depth will be on January 28th. So that'll be 28 days. So it'll be y equals 68 minus 2 inches a day times 28 days. So that'd be 68 minus 2 times 28 is 56. And 68 minus 56 gives me 12 inches of snow. So it started at 68. By the time you get to January 28th, you're only going to have 12 inches of snow. Now, when you choose the 12 inches, it'll give you a graph that starts over here at 70. And down here, it goes up to 32 days, starts at 0. You want the one that starts here about 68, and down here at 28 is about 12 on the side, okay? A little above the 10, but it don't matter. Once you solve that for the 12 inches, there's only one answer that has 12 inches with the correct graph, okay? All right, the last one. The following situation can be modeled by a linear function. Write an equation for the function and use it to answer the questions. Be sure you clearly identify the independent and dependent variables. So the price of a particular model car, so model car, for a particular model car is $13,000 today. Rises with time at a constant rate of 910 per year. So $910 per year, it rises. And then they want to know, how much will a new car of this model cost in 3.2 years? So how much in 3.2 years? So this is just like we've been doing. I would do my Y equals 13,000 because that's your starting amount. It increases, so that'll be plus 910 per year, means times my years, which will be my X. Oh, I think on there they're doing it times T for time, okay? So 910 times the T, which is the number of years, add that to the 13,000, that'll give me my final amount. So the independent variable has to be the time, which is the number of years. Remember, time can never be a dependent variable, okay? Dependent variable is going to be the price. The linear function for this, let me see how I put that. Is P, they're using P for price, equals to 13,000 plus 910 times T, which is for the time. All right, now 3.2 years, I plug that into that, so I get P equals 13,000 plus 910 times 3.2 years. Doing that, I came up with 15,912. So watch, y'all. 13,000 plus parentheses 910 times 3.2, and it gave me perfectly to the nearest dollar, which is what they wanted. All right, then I said, this is probably not likely because it's highly unlikely that a car is going to go up every year for the same model. So a 18 Chevy Camaro is not going to increase in value, and in the year 2020 the same 18 Camaro will be worth more money than what was paid for back then, okay? So y'all, that looks like all of the study guide for the final exam. So I want y'all to practice that, and then next class we're going to go over any of these problems that you don't know how to do. So I'm going to stop my share, and then I'm going to stop the video and see y'all in class.